So today we have to discuss our seventh practical. Just wait. Okay. So today we have to discuss our seventh practical, and this practical it is basically the preparation of bakelite and urea formaldehyde resin. Okay. Means we have to discuss the preparation of some polymer molecules. Okay. And I think you all of you know what is addition polymer and what is condensation polymer. Briefly, addition polymers are the polymer which are during their preparation, no side product form. Okay, as I think we have discussed in case of theory, we have discussed in theory. Uh, I think all of you remember we are discussing about addition polymerization, and in that we have discussed in addition polymerization when the monomer units they polymerize, they undergo reaction for the formation of polymer, no side product or waste product form. So that type of polymerization we call it as a addition polymerization. And the second type of polymerization it is condensation polymerization. Condensation polymerization means during the formation of polymer, a condensation reaction takes place, and during condensation reaction, small molecules comes out during the reaction. Okay. मतलब क्या है, मान लीजिए आपके पास मोनोमर मॉलिक्यूल है. Suppose we have monomer molecule M. So M monomer molecule it react with another monomer molecule M. Means you have M plus M. So when they react with each other, a small molecule comes out. That small molecule it may be some water molecule or it may be something else. Okay. So during the polymerization reaction, if you have release of a small molecule as a byproduct, okay, if that is the case during polymerization, that polymerization we call it as a condensation polymerization. So in today's practical, we have to discuss condensation polymerization, basically for the synthesis of a bakelite and a urea formaldehyde resin. Let me share the slides, then we will continue further. I hope right now all of you can see the slides. The slide दिख रहा है सभी को?
Yes, sir.
Okay, good. So our today's practical it is the preparation of a bakelite and urea formaldehyde resin. Okay. So bakelite and urea formaldehyde resin, both of these, they are a condensation polymer. Means during their preparation, during their synthesis, you will have the release of small molecules as byproduct in addition to your polymer molecules. Okay. So first we will discuss the theory one by one. Okay. So first we will discuss the preparation of bakelite. Just wait. Then we will discuss the preparation of urea formaldehyde resin. Okay. Remember both of these, they are a condensation polymer. In theory, later on, we'll discuss in the theory class what are the different steps involved in the condensation polymerization. If you remember in the theory, we have discussed addition polymerization. We call it as a chain growth polymerization. Chain growth means you have formation of some chain, and that involves three main steps: chain initiation, chain propagation, and chain termination. And on the other hand, in condensation polymerization, we call it as a step growth polymerization, where we have steps only. Okay, so that we will discuss in the theory class. So here we will discuss how we can prepare bakelite. So bakelite, or we can also call it as phenol formaldehyde resin. Okay. Phenol formaldehyde resin or bakelite, both are same thing. Bakelite, it is the commercial name of phenol formaldehyde resin. ठीक है, बुक्स में आपको बैकेलाइट भी लिखा मिल सकता है. You can also see it will be written like phenol formaldehyde resin. Okay, so both are same thing. Bakelite, it's a commercial name of a phenol formaldehyde resin. So it's a condensation polymer which is prepared, means which we can synthesize by condensation reaction between phenol and formaldehyde in the presence of an acid or base catalyst. Okay. I think if you remember, we have discussed briefly about the bakelite in case of in theory class. Okay. This we can synthesize simply by performing a condensation reaction between phenol and formaldehyde by using an acid or base as a catalyst. Okay. So this polymer, bakelite or phenol formaldehyde resin, it is first prepared by Leo Baekeland. Okay. It is first prepared by Leo Baekeland. That's why it's named as bakelite. So bakelite, it's a type of a thermosetting polymer. And now what are thermosetting polymer? We have discussed in the class thermoplastic and thermosetting polymer. So thermoplastic polymers, you can make them soft. I'm talking about thermoplastic. You can suppose this side we have temperature. Okay. So you can make them soft by heating, and if you cool them, they become hard. If you again heat them, they become soft. So they have this kind of reversible nature. They are called as thermoplastic polymers. Okay. Thermosetting polymers simply means that this side temperature, and once suppose when you prepare them, okay, during their preparation, they are first soft at high temperatures. So once you cool them, they become hard. Okay, so means we are decreasing the temperature. H represents hard air, okay, and S represents soft air. Okay, so just wait. S represents soft air and H represents hard air. So once when you prepare them, basically we perform reaction by using some temperature conditions. So first they are hard, soft at high temperature. Once you cool them, they become hard. Okay, and once they become hard, when you again heat them to get the soft material, you will not get. Okay, means they are not reversible in nature. You cannot make them soft and hard by changing the temperature. Once they become soft, hard, they will stay in that state. You cannot make them soft by heating again. Okay, जैसे कि आपके प्रेशर कुकर का जो हैंडल होता है ना, that is made up of bakelite. That is very hard material. If you try to heat that hard material, okay, you will see it will not make soft material. वो soft material नहीं बनाएगा. अगर आप उसको heat करोगे, it will break down into some solid particles. वो क्या, उसके वो भुरभुरा के गिर जाएगा, मतलब कि वो भुरभुरा जाता है. ठीक है, वो लिक्विड नहीं बनेगा, सॉफ्ट नहीं बनेगा. ठीक है, वो क्या है, some different kind of hard material it will give you. Okay, ठीक है, वो भुरभुरा के गिर जाएगा. You can try yourself. Okay, if you have a spare pressure cooker handle. So that is the nature of thermosetting polymers. And bakelite, it's a type of thermosetting polymer. Okay. So, okay, I already discussed this thing. Thermosetting polymer, it's a polymer that is formed as a reversible hard material when a viscous or soft free polymer sample is heated. Okay. So this hardening, the hard nature of a bakelite upon heating, okay, it is due to the formation of an extensive cross-linking between the different chains. ठीक है, I told you कि जब इसको हीट करते हो ये एक हार्ड मटेरियल बना देता है. ठीक है, सॉफ्ट मटेरियल नहीं बनाता. जबकि थर्मोप्लास्टिक के केस में if you heat then they become soft. So here if you heat them they become hard. Okay, this hardness, it is because of the fact that when you heat thermosetting polymers or bakelite, they form extensive cross linking between different polymeric chains. होता क्या है कि आपकी जो different chains होती हैं, for example you have these chains, when you heat them they form cross linking between the different polymer chains, and because of this it creates a three-dimensional network. Okay, you will have three-dimensional networks. So because of this three-dimensional network, upon heating it becomes solid. Okay, okay, even at high temperature. Okay, when you heat them. Okay, so this is the property of bakelite. So now how we can synthesize this bakelite? For this synthesis of bakelite, we have to simply perform a reaction, perform a condensation reaction between formaldehyde and phenol in the presence of some acid or some base. Okay, remember in chemistry, condensation reactions are the reactions where small molecules comes out as a byproduct. Usually in chemistry, water molecules comes out as a side product. Okay. केमिस्ट्री में अगर आपने कभी बहुत बड़ी पढ़ा होगा, आपने पढ़ा होगा एल्डोल कंडेंसेशन, या सुना भी होगा एल्डोल कंडेंसेशन. तो वहां पे क्या होता है? ठीक है, तो वहां पे भी एक वाटर मॉलिक्यूल निकलता है. ठीक है, व्हेन टू एल्डिहाइड्स दे ज्वाइन विद ईच अदर. ठीक है, तो उसको हम एल्डोल कंडेंसेशन कहते हैं. इट्स अ टाइप ऑफ कंडेंसेशन रिएक्शन. Okay. So same thing will you see here. Okay. Just wait. So here I will show you the reaction, how this reaction goes on. So we will discuss the reaction both. Let me see. Okay, so we will see the reaction in the presence of acid as the catalyst. Okay, so what will happen here now? So in the presence of acid catalyst, in the presence of acid catalyst, first there is formation of ortho and para hydroxymethylphenol. Okay, so I told you what happened during the reaction. For the reaction we take phenol plus formaldehyde. So we have this one is our phenol and this is our formaldehyde, HCHO. It is our formaldehyde and we are using acid as a catalyst here, H positive. Okay, so in the presence of acid, first we have the formation of ortho and para hydroxy methylphenols. Okay. What we will have? We will have the formation of first this ortho hydroxy methylphenol, or we have formation of a second isomer of this compound, that is para hydroxy methylphenol. Okay. So how this reaction is going on? You can simply see here. You have formaldehyde. So formaldehyde contains carbonyl group, and in the presence of acid, this carbonyl group, this oxygen, okay, C double bond O, this is carbonyl oxygen, okay, carbonyl group. I think all of you studied chemistry, so you know what is carbonyl group meaning. Carbonyl group meaning C double bond O group. Okay, so in the presence of catalyst, first thing what happened, there is protonation of a carbonyl group, because we are adding H positive here. So this H positive, it attacks the oxygen of the carbonyl group. Okay. So this carbonyl oxygen, it attacks the proton first. So that results in the protonation of the carbonyl group. So now if you see here, oxygen, it has positive charge here. Okay, because oxygen uses its lone pair to attack the H positive. Okay, so here this oxygen, it has positive charge. So this makes this carbonyl carbon electropositive in nature, means electron deficient in nature. Okay, this makes this carbonyl carbon electropositive in nature, means electrophilic center generate हो जाता है यहाँ पे. Okay, so now what happened in the next step? Phenol, this carbonyl carbon, see the second step here. This carbonyl carbon, it is electrophilic center here. Now the phenol, it attack this carbonyl carbon, which is electrophilic in nature. Okay, so how it attack? Its attack, it is favored by the presence of a OH group on the benzene. Okay, the lone pair of oxygen, it goes here, and the pi electron of the benzene ring present at the ortho position, it attacks the carbonyl carbon. See the arrangement of electrons like this way. Okay, so you will have this kind of structure. Okay, once you have this kind of structure, the benzene ring, it loses one of its proton present at the ortho position. See here, this hydrogen, it is present on the benzene. Okay, so this compound you are getting after reaction, attack of a phenol on the carbonyl carbon, you will get this structure. So this is not benzene now. Okay, if you see the structure of benzene, it is not benzene. It is not aromatic. It does not contain 3 double bonds. ठीक है, reaction हमारा हो चुका है. Now benzene, it is not aromatic here. So benzene loses proton so that it become aromatic again. Means it will contain now 3 double bonds after losing the proton. Okay, so the proton from ortho position, it is released as H positive, okay, by the benzene, and see the arrows here, that recreates the aromatic character of the benzene, and you will get here orthohydroxymethylphenol. This is now your orthohydroxymethylphenol. Okay. So this is the reaction mechanism for the synthesis, for the formation of this orthohydroxymethylphenol. Okay. In the similar way, para-hydroxymethylphenol it will form. Okay, the same mechanism. Okay, but now you have to just make a slight difference. How? Now the attack of phenol, it is taking from this para position on the carbonyl carbon. यहाँ से अटैक होता है. वो कैसे होता है? सब कुछ वही रहता है. ठीक है, फिनोल के इलेक्ट्रॉन यहाँ जाते हैं और ये इलेक्ट्रॉन दे विल गोज कम हियर, and this double bond it attack on the carbonyl carbon. Okay, if you do like this way, you will have the formation of this para hydroxy methylphenol. ठीक है भी? ठीक है. अब इस केस में क्या होगा? इस केस में भाई समझ में आ रही है बात? यहाँ पे क्या होगा कि ये बॉन्ड यहाँ पे जाता है. Okay, in case of para attack, and this bond attack here. Now in this structure, the product structure, the CH2 group, it will be on para position. यहाँ पे रहेगा ये. ठीक है, यहाँ पे आपका CH2 ग्रुप आएगा. यहाँ पे CH2OH ग्रुप आपका यहाँ पे आएगा. Now you will have this group here on para position and hydrogen also here. ठीक है, और डबल बॉन्ड यहाँ पे रहेगा ऐसे. ठीक है, so this hydrogen it goes here. ठीक है, or this goes here, and rest of the thing it is same. This goes here. ठीक है, similarly होगा. बस आपका पैरा पोजीशन इन्वॉल्व होता है अटैक में. Okay, so if the attack takes place like this way, you will have the formation of this para-hydroxy methylphenol. Okay, so remember there is 50-50 possibility. Attack can take place through ortho position or through para position. Okay, so you will get a mixture of products, ortho-hydroxy methylphenol and para-hydroxy methylphenol. Okay, once they formed, once you have formation of these things, they then form first the linear polymer that is known as novolac. Okay, आपके पास जब ये दोनों आ जाते हैं, they will first form the linear polymer, and that linear polymer it is known as, देखिए अभी पॉलीमर नहीं बना है हमारे पास, अभी हमारे पास सिर्फ ये बना है ऑर्थो हाइड्रोक्सी मिथॉल और पैरा हाइड्रोक्सी मिथाइलफिनोल. ओके, ये हमारे पास बने हैं. These two things, they form the linear polymer. Okay, they join and they form a linear chain, and that linear chain, linear polymer, we call it as a novolac. Okay, so you see here we have this orthohydroxymethylphenol. This orthohydroxymethylphenol, it react with phenol. Okay, it react with phenol under acidic conditions, and it will give you linear polymer like this way. Okay, CS2 benzene ring, CS2, then again benzene ring phenol, CS2, then again phenol, CS2, then again phenol. Like this way, the linear polymer you will get. That linear polymer, it is called as Novolac. Okay. And how this reaction taking place, you can see here in the reaction mechanism here. Okay. So all this taking place under acidic condition. So first you have your this one, orthohydroxymethylphenol. Okay. So in the first step, what happened? There is protonation of a methyl alcohol group. Okay, CS2OH group. इसका प्रोटोनेशन होता है आपका फर्स्ट स्टेप. Okay. So if you see here, you will have a protonation. It goes here, this proton. So you will get your this molecule where the oxygen, it will have now positive charge. Okay. Yeah. देखिए भी ऑक्सीजन OH क्यों ले रहा है OH पॉजिटिव? क्योंकि ऑक्सीजन के पास 2 लोन पेयर होते हैं. ठीक है. और उनमें से एक लोन पेयर क्या होता है? इट इंटरेक्ट विद H पॉजिटिव. जब वो इंटरेक्ट करता है तो ऑक्सीजन के ऊपर पॉजिटिव चार्ज आ जाता है. ठीक, क्योंकि उसने अपने इलेक्ट्रॉन एक हाइड्रोजन को दे दिया है, उसकी वजह से ऑक्सीजन के ऊपर पॉजिटिव चार्ज आ जाता है. ओके, सो दिस इज द केस हियर. ओके, you have positive charge on the oxygen. Okay, now since the oxygen it is electron deficient, the bond between CH2 here, this bond CH2 and oxygen, it breaks. ठीक है, हमारे पास क्या हो रहा है? द बॉन्ड बिटवीन, जो हमारे पास ये बॉन्ड है, ठीक है, ऑक्सीजन और कार्बन के बीच में, CH2 के बीच में. नाउ दिस विल ब्रेक. ओके, so this will break. It will give you release of a water molecule. Water molecule comes out. Okay, you see we have written here water molecule. Okay, so when this bond breaks out, it will release the water molecule, but it will create positive charge on the carbon. Okay, see the next product. Okay, here if you see in this structure, the CH2 group, it has positive charge here. Okay, so now here what happened? The lone pair of a phenol, the lone pair of a phenol group, okay, that is oxygen. Okay, it involves, ठीक है, आपकी क्या जो ऑक्सीजन के ऊपर जो लोन पेयर है, that participates here. Okay, it goes like this way, and this double bond, it shifts to this bond. Okay, so when this happens, you have a formation of this kind of structure. Okay, so this molecule, okay, if you see this molecule, when the lone pair of oxygen involves, one side it remove the electron deficiency of a CH2 group by making the double bond. Okay, see this position. Okay, it is removing the positive charge of a CH2 group by making double bond, but side by side it creating positive charge on the oxygen. यहाँ पे हमारे पास क्या OH ग्रुप जो है उसके ऑक्सीजन पे we have positive charge. ओके, तो ऑक्सीजन पे पॉजिटिव चार्ज तो भाई रह नहीं सकता. ओके, ज्यादा देर तक. नाउ व्हाट हैपेंस? We also use phenol here. Okay, so now the attack of a phenol takes place on the CH2 group. What happened now? The attack of a pi electron of benzene present at the ortho position, they involve in the attack. They attack the CH2 group. Okay, so it attack like this way. You can see the arrows. This attack, it takes place with the help of a OH group of a phenol. ठीक है, उसके जो lone pair है, that involves. Okay, and that favor the attack on the CH2 group here. And you can see here the movement of electrons. Okay, so when this happens, you will have formation of this intermediate. Okay, let's see here. Okay, so you have this intermediate. Okay, so this part, it is our orthohydroxy methyl phenol part. Okay, so now we have this part. Now this molecule, if you see one benzene, it is completely aromatic in nature here. It contains 3 bonds. And the second benzene, it contains just 2 bonds here. Okay, इसका मतलब कि ये aromatic नहीं है. I think maybe you people know how we can describe the aromatic characters. Okay, the aromatic character, aromatic system वो होता है, उसकी 3-4 चीजें होना जरूरी है aromatic system में. ठीक है, first क्या, the molecule should be planar, molecule should be resonance stabilized, and it should follow the Huckel rule. Huckel rule means it should have 4n plus 2 pi electrons. 4n plus 2 pi electron it should have, means it should contain 6, 10, 14, 18 pi electrons. Okay, if you see benzene here, one benzene, it contains 3 bonds, 3 double bonds, 3 pi bonds. 3 pi bonds means it has 6 electrons. Okay, and दूसरी बेंजीन देखिए यहाँ पे कितने हैं पाई इलेक्ट्रॉन्स, 4 पाई इलेक्ट्रॉन्स है. ओके, एक डबल बॉन्ड वो हम 2 इलेक्ट्रॉन लेके चलते हैं यहाँ पे. ओके, so 2 plus 2, 4 electrons. So according to Huckel rule, 4 electrons, it does not comes under aromatic compounds. So now we have to regenerate aromatic character in the second benzene here. So one of the proton, okay, of benzene which is present at the ortho position here, it is lost by this benzene. Okay, and that favors the formation of a, or that results in the regeneration of a aromatic character in the benzene ring, in the second benzene ring. Okay, यहाँ पे देखिए, just wait, जो ये वाला बेंजीन है ना, this is not aromatic here. Okay, so यहाँ पे क्या होता है कि one of the hydrogen that we have here, it lost by this benzene. Okay, and that's why we are getting our product in which you see both of the benzene rings, they contain 3 double bonds, means 6 pi electrons. Both of the benzene, they are aromatic here. Okay, so this molecule you get 2 phenols. One phenol is this one, and second phenol, it is this one, which are connected by a CH2 bridge, CH2 molecule. So once this molecule it is formed, this one, this molecule, then now if you see here, we started from one benzene ring. Now here we have 2 benzene rings. Okay, now this molecule, it then react with formaldehyde. Okay, formaldehyde. Okay, means one of the phenol in this molecule, it react again with, ठीक है, ये हमारी जो ऊपर मॉलिक्यूल बना है ना, ठीक है, इसमें 2 फिनोल्स हैं हमारे पास, एक राइट साइड पे, एक लेफ्ट साइड पे. सो वन ऑफ द phenol here, it react with formaldehyde. Okay, it react with formaldehyde to give you this kind of molecule where you have CH2OH group in one of the phenol molecule. ठीक है, मतलब कि ये वाला जो रिएक्शन दोबारा से हो रहा है, ये वाला, जैसे ये बनाया ना मैंने उधर ऑर्थो हाइड्रोक्सी मिथाइल फिनोल, ठीक है. सो सिमिलर रिएक्शन इट इज टेकिंग प्लेस हियर इन दिस मॉलिक्यूल. ठीक है, यहाँ पे दो फिनोल्स हैं, इनमें से एक फिनोल इट रिएक्ट अगेन विद फॉर्मल्डिहाइड टू गिव यू दिस मॉलिक्यूल. See the product CH2OH. Then this molecule it again reacts with in the similar way. ठीक है, it again repeats the steps from 1 to 6. ये अगेन ऐसे ही रिएक्ट करता है जैसे कि ये वाला सिंपल फिनोल विद CH2OH ग्रुप रिएक्ट किया. ठीक है, ये ऐसे ही रिएक्ट करता है अगेन. ठीक है, और जब ऐसे रिएक्ट करेगा तो एक बेंजीन और ऐड हो जाएगा आपके मॉलिक्यूल के अंदर. यू विल गेट 3 बेंजीन्स. ओके, अब जब ये बहुत बारी रिपीट कर जाएगा, बहुत सारी बेंजीन ऐड हो जाएगा, इट विल मेक ए लीनियर पॉलीमर. ओके, दिस काइंड ऑफ स्ट्रक्चर यू विल सी, लीनियर स्ट्रक्चर, लीनियर पॉलीमर स्ट्रक्चर. वी कॉल दैट स्ट्रक्चर एज ए नोवोलैक. ठीक है, उसको हम क्या बोलते हैं, नोवोलैक बोलते हैं. ठीक है भाई, समझ में आई बात थोड़ी सी? ठीक है, देखिए रिएक्शन मैकेनिज्म इट्स पॉसिबल कि हम आपसे रिएक्शन मैकेनिज्म पूछ लें, तो जो मैंने ये आपको दिया है यहाँ पे मैकेनिज्म, ठीक है, मैंने खुद लिखा है, तो आप लोग एक बार ट्राई करके देखना, खुद लिख के देखना. व्हेन यू ट्राई राइट योरसेल्फ, ओके, यू विल अंडरस्टैंड. ठीक है, कि एरोस कहाँ से कहाँ जा रहे हैं, यू विल अंडरस्टैंड इजीली. ओके, सो वंस वी हैव, ओके गुड, सो वंस वी हैव दिस नोवोलैक, देन देखिए ये हमारे पास लीनियर पॉलीमर बना है अभी. ओके, अभी इसकी क्रॉस लिंकिंग नहीं हुई है. आफ्टर दैट वंस वी हैव दिस लीनियर पॉलीमर, it will undergo cross linking upon heating. Okay, so this is our novolacc. Okay, and in the presence of SCO, SCHO and acid, it simply form bakelite. It form cross linked structure. Okay, it's very difficult to explain here how it is forming this structure. Okay, but basically you can remember कि जो this novolacc here, it is formed through the formation of this molecule. ठीक है, जब आपके पास CH2OH जो होता है वो ऑर्थो पोजीशन पे होता है. ठीक है, आफ्टर फॉर्मल्डिहाइड रिएक्शन. ठीक है, when you perform further reaction, you have first CH2OH formation at para positions. ठीक है, यहाँ पे आपके क्या बन जाता है, पैरा पोजीशन पे फर्स्ट. when you do reactions further, you will have formation of here CH2OH para position पे. Okay, and this formation, this CH2OH, it then react with similar chain. Okay, it then react with novolacc chain again. Okay, अब देखिए आपने लास्ट टाइम यहाँ पे क्या किया था, if you see here, हमने यहाँ पे बताया कि जो हमारा CH2OH है, अल्टीमेटली इसकी रिएक्शन फिनोल के साथ हो रही है थ्रू ऑर्थो पोजीशन अटैक. ठीक है, अब होता क्या है कि एक नोवोलैक की चेन के अंदर तो हमारा CH2OH लग जाता है हर जगह पे पैरा पोजीशन. ठीक है, पहले तो ये बनता है. ठीक है, आफ्टर दैट दिस नोवोलैक इट क्रिएट CH2 हियर. ठीक है, सिमिलर टू दिस वन. ठीक है, पैरा पोजीशन पे हमारे पास क्या बनता है, दिस काइंड ऑफ मॉलिक्यूल फॉर्मेशन CH2 एट द पैरा पोजीशन इन नोवोलैक. हमारा यहाँ पे रख लिया आप, यहाँ पे नोवोलैक की स्ट्रक्चर देखिए, यहाँ पे हमारे पास क्या CH2 ग्रुप जनरेट होता है. after reaction with, okay, when we do next heating, okay, यहाँ पे क्या CH2 ग्रुप जनरेट होता है हर जगह पे, similar to, okay, this step. अब होता क्या है कि जब एक बारी CH2 ग्रुप जनरेट हो जाता है नोवोलैक के स्ट्रक्चर में, ठीक है, दिस अटैक द सेकंड पॉलीमर चेन ऑफ नोवोलैक, ठीक है. अब क्या होती है, हमारी दूसरी नोवोलैक की चेन होती है सिंपल नोवोलैक की चेन, ठीक है, जिसमें कि कोई CH2 ग्रुप नहीं है, ठीक है, वो अटैक करती है इन सारे CH2 पे लाइक फिनोल. आप सिंपली याद रखिए कि जो आपका ये वाला ग्रुप है, ठीक है, आप इसको मान के चलिए कि यहाँ पे क्या है, CH2 ग्रुप क्या है, पैरा पोजीशन पे है, ठीक है, इसको फॉरवर्ड करिए आप CH2 ऑर्थो पोजीशन पे, इसको आप मान के चलिए कि इट इज एट द पैरा पोजीशन, एंड ये क्या है, हमारी नोवोलैक चेन है, ठीक है. तो हमारे पास CH2 ग्रुप इसके पैरा पोजीशन पे है. जब पैरा पोजीशन पे रहेगा, अल्टीमेटली यू विल गेट दिस इंटरमीडिएट हियर, which we will have CH2 group at the para position. So one of the Novolec chain, it form intermediate like this way. अब हमारे पास क्या दूसरी Novolec chain है, ठीक है. अब दूसरी Novolec chain क्या सिंपल है, as it is like this way. So इस चेन का जो पैरा ग्रुप है, that will attack here at the para position at the CH2 group, ठीक है. तो वहां पे क्या लिंकिंग हो जाती है, CH2 ग्रुप की लिंकिंग हो जाती है इन बिटवीन टाइम, ठीक है. तो उसकी वजह से क्या होता है हमारे पास, वी विल गेट दिस काइंड ऑफ स्ट्रक्चर, बेकेलाइट स्ट्रक्चर. सिंपली क्या है कि टू नोवोलैक चेन्स दे क्रॉस लिंक विद ईच अदर अपॉन फर्दर हीटिंग, ठीक है. सो व्हेन दिस नेटवर्क फॉर्म, यू विल हैव द फॉर्मेशन ऑफ अ बेकेलाइट, ओके. तो इसका मतलब क्या है कि यहां तक नोवोलैक तक, up to Novolec you have a, okay, up to Novolec it's a linear polymer, and if you further heat this reaction mixture, it will immediately convert it into this bakelite, this cross-linked polymer, and this cross-linked polymer, it is thermosetting polymer. मतलब कि आप हीट कर दोगे सिस्टम को तो ये क्या एकदम से हार्ड मटेरियल बन जाएगा, and you cannot make it soft again by further heating more, okay. So this is the chemistry of bakelite, how you can form the bakelite, okay. This is the reactions, okay, what is going on. So now we will see how we can synthesize this bakelite in the laboratory. So for the synthesis of bakelite, it's very easy synthesis, okay. What we have to do, okay, one thing I am missing here, requirement, okay, requirement you can write yourself, okay. What you need glacial acetic acid, you need 40% formaldehyde, you need concentrated HCl solution, okay. So that thing you can write, you need beaker, you need distilled water, etc. Okay. So you try to write the requirement yourself. So in procedure, what we do, we take 5 ml of glacial acetic acid. We take 5 ml of glacial acetic acid and 2.5 ml of 40% formaldehyde solution in a 250 ml beaker. Okay, means we will take a beaker. In that beaker, we first add glacial acetic acid, 5 ml. We will add 40% formaldehyde solution, and in this mixture, then we add 2 grams of phenol. So we are adding first 3 things: glacial acetic acid, formaldehyde, plus 2 grams of phenol. So after that, into this beaker, after adding these 3 things in the beaker, we will add concentrated HCl. Okay, and okay, we have to add concentrated HCl. 1 to 2 ml carefully. Okay, then we have to heat this mixture with constant stirring for 5 to 10 minutes. Okay, so we will heat this mixture by 5 to 10 minutes with constant stirring. Okay, so हम क्या करेंगे? We will use a glass rod here, okay, to stir this mixture. So during this time, you will see a large insoluble mass. It will be produced in this reaction. Okay, आपका क्या होगा? एक पॉलीमर बन जाएगा आपका 10 मिनट के अंदर अंदर ही. Okay, which will be, आपको initially क्या होगा? All the things they are soluble in the mixture. Initially क्या होगा? Liquid होगा. जब आप उसको mix heat करना start करोगे, you will see a solid insoluble mass. It will appear. Mass means some material will appear. Okay, and after 10 minutes, you will take out that material and wash that material several times with water to remove the formaldehyde, left formaldehyde, to remove the acid or other impurities. Okay, simply that you have to do. Okay, synthesis is very simple. You have to take glycolic acid, formaldehyde, and phenol in the beaker. Then you have to add HCl in the beaker. You have to heat for 5 to 10 minutes. You will see the formation of a formation of a solid material inside the beaker. Okay, and after that, you have to just filter that solid material and wash with distilled water several times. Okay, then you have to dry that compound, dry that material, and check its weight. Okay, how much amount you obtain, that you have to calculate just by weighing. Okay. Okay. So during the preparation, you can see observations. You can see what is happening in the reaction mixture when you increase the temperature. Okay, that you can see. So when you heat this beaker, initially temperature will be less, nearly 40 to 35 degrees Celsius. So at that time, you will see no change in the reaction mixture. Okay. Means clear reaction mixture you will see. When you heat somewhere in between 45 to 50 degrees Celsius, you will see some turbidity in the reaction mixture. Means solution will not be clear now. Okay. And when you heat the reaction mixture near about 55 to 60 degrees Celsius, you will see, okay, you will see large turbidity in the reaction mixture. So that will indicate you have polymerization goes on in the reaction mixture. Okay, इस समझ में आ गया कि हम बैकेलाइट कैसे बना सकते हैं?
Yes. Yes, sir.
Yes, sir.
ठीक है, ये बहुत इजी एक्सपेरिमेंट है. इसका आपको रिएक्शन मैकेनिज्म थोड़ा सा लग रहा होगा कि डिफिकल्ट, बट इट्स आल्सो इजी. इफ यू राइट वन टाइम on the paper, you will understand how the reaction going on. Okay. So this is one of the polymer that we have to synthesize. The next polymer we have to synthesize, that is urea formaldehyde resin. Okay. This one, urea formaldehyde resin. Again, urea formaldehyde resin, it is a condensation polymer, and it is prepared from urea and formaldehyde. In case of bakelite, we use phenol and formaldehyde. Here, in case of urea formaldehyde polymer preparation, we are using urea and formaldehyde as our monomer in the presence of sometimes neutral, or we can also use acidic conditions. Okay. You understand? So in case of urea formaldehyde reagent, we perform a condensation reaction between urea and formaldehyde under neutral or under acidic conditions. Okay. So when you treat urea, or when you react urea with formaldehyde, you will have the formation of a monomethylol and dimethylol urea. Okay, so this is urea, NH2C double bond O NH2. And interestingly, urea, it is the first organic molecule synthesized in the laboratory. Okay. Urea, it was the first synthesized organic molecule in the laboratory. सबसे पहले यूरिया सिंथेसाइज किया गया था लैब के अंदर, जो ऑर्गेनिक मॉलिक्यूल जो सबसे पहले सिंथेसाइज किया गया है, ठीक है, दैट इज यूरिया. So this urea, it can react with formaldehyde in two ways. Okay, this is our urea. It can react with one molecule of formaldehyde to give you this monomethyl urea. You see, one of the amine, it is converted into NHCH2OH. This is monomethylol urea. And in the similar way, two molecules of formaldehyde, that is HCHO, it can react with urea to give you dimethylol urea. Okay, that is NHCH2OH on both sides. Okay, so like this way, urea react with formaldehyde. Understand? Remember how the reaction of this NH2 group with formaldehyde is taking place. This reaction, it is similar as we have discussed in the case of here, in the case of phenol. जैसे यहाँ पे reaction हो रहा है, in the similar way reaction is going on in case of urea. वहाँ पे क्या है? यहाँ पे क्या है? pi bond of benzene it is attacking. वहाँ पे क्या है? यहाँ पे हमारे यूरिया के केस में this NH2 it attack this carbonyl carbon. Okay, and that favors the formation of this NHCH2OH group. Okay, mechanism is similar. Just difference is that here we have NH2 group involving in the attack, और phenol के केस में pi electrons of benzene it is involved in attack. Okay, and I told you attack it can take place in two ways. One molecule of SCHO it can react to give you methylol urea, and two molecules of formaldehyde it can react to give you dimethylol urea. Okay, so for the formation of urea formaldehyde resin, this dimethylol urea it undergo polymerization. Okay, this dimethylol urea it undergo polymerization. Okay, so how it undergo polymerization? You can see this reaction there. Okay, remember this is a condensation reaction, means you will have the release of some small molecule as a byproduct here. Okay, so it's very simple reaction. If you see here, we have one molecule of dimethylol urea here. This is our second dimethylol urea, and this is our third methylol urea. Okay, so different monomeric species of dimethylol urea, they undergo condensation reaction here. Means release of some water molecule during the reaction. Okay. तो देखिए होता क्या है, this dashed squares it indicates here where the reaction takes place and what molecule it is coming out. Okay, so OH and H, what they will make? They will make water molecule there. Okay, देखिए होता क्या है, this NH2, suppose this NH2, okay, see the central dimethylol urea. होता क्या है, the nitrogen of the dimethylol urea, it has lone pair of electron. Basically, it attack the CH2 group of CS2 group. It attack like this way. Okay, so when it attack, it releases OH negative. Okay, means OH negative, it goes outside, and this OH negative, it basically it's remove the proton from nitrogen. ठीक है, देखिए नाइट्रोजन पे लोन पेयर है इलेक्ट्रॉन के, ठीक है, तो होता क्या है, the nitrogen hydrogen bond, it goes to nitrogen, the lone pair of the nitrogen, it attacks the CS2 group, and this CS2 group, it favors the release of OH as OH negative, and this OH negative, it attacks the hydrogen. So this is the cycle. So यहाँ पे अगर आप ध्यान से देखो, so जो OH and H, they are coming out, and nitrogen, it is making bond with CS2. Okay, तो हमारा होता क्या है, यहाँ से वाटर मॉलिक्यूल बाहर निकल आता है, H2O. हमारे पास क्या है, H2O बाहर आ रहा है. ओके, और नाइट्रोजन का बॉन्ड CS2 के साथ हो रहा है. ठीक है, सो सेम टाइप ऑफ रिएक्शन इट इज टेकिंग प्लेस हियर. ठीक है, if you see other side of this dimethylolurea, similar reaction taking place. Okay, so that's why you have linking between two dimethylolurea here. Okay, ठीक है, अब सेम रिएक्शन हमारा सेंट्रल डाइमिथाइलोयूरिया का, इफ यू सी ऑन द राइट हैंड साइड, एक और डाइमिथाइलोयूरिया है, इसके साथ हो रहा है. ठीक है, सेम रिएक्शन, and that also result in the formation of a NCH2N bond here. Okay, these bonds, हमारे पास ऐसे bonds बन रहे हैं बीच में. Okay, with the release of a water molecule. ठीक है, so हमने यहाँ पे सिर्फ 3 डाइमिथाइलोयूरिया लिए हुए हैं. ठीक है, in actual practice there is number of a dimethylolurea molecule connect like this way. आपके पास 50 और 100, 200, 300 number of a dimethylolurea molecules, they connect like this way. ठीक है, and they result in the formation of this kind of a cross-linked structure. This is your urea formaldehyde resin. Okay, so let's see how we can perform its synthesis in the laboratory. So it's very simple. Requirements, you can see the procedure and the chemicals that you see and the operators that you see, you can write in place of requirements. Okay, so what we will do, we will take a beaker, and in that beaker we will add 40% formaldehyde, 5 ml, and after that we will add in this beaker 2.5 gram of urea. We will add into this beaker. Okay, and after adding formaldehyde and urea, we will add few drops of concentrated sulfuric acid with constant stirring. Okay, so we added 3 things. First, formaldehyde 40%. Remember, formaldehyde, we do not have 100% formaldehyde solution. ठीक है, formaldehyde क्या होता है, वो बहुत unstable होता है. ठीक है, you cannot store it as 100%. So जो हमें मिलता है commercially available, it is 40% solution of formaldehyde. Okay, so हम क्या करेंगे, we will take a beaker, and in that beaker we will add first formaldehyde 5 ml, and in that 5 ml formaldehyde we will add 2.5 grams of urea, NH2 C double bond O, NH2 urea. with constant stirring. And after that, we will add few drops of a concentrated sulfuric acid. Okay. Remember, sulfuric acid, it is acting as a catalyst here. Okay. We can do this reaction even without catalyst. But if you don't add catalyst, the reaction will be slow. Means it will take some more time relatively to complete. And we want our reaction should complete fast. So that's why we are adding acid here. Okay. So after adding acid with constant stirring, you will see a solid mass immediately appear in the beaker. ठीक है? Acid डालने के बाद immediately you will see a solid product. It will appear in the beaker. Immediately. Reaction will take place immediately. Within 1, 2, 3 minutes, it will take place. You will see solid product in the beaker. Okay. So once you see you have a solid in the beaker, you have to take out that solid. Okay, that solid, it will be white in color. You have to take out that solid, wash with water several times, and you have to dry that solid by using rough filter paper. Okay. मतलब क्या है, आपके रफ फिल्टर पेपर पे आपने जो सॉलिड आया उसको रख देना है और रफ फिल्टर पेपर को प्रेस करना है. ठीक है. उससे क्या है कि उसके अंदर जो वाटर थोड़ा बहुत होगा वो निकल जाएगा. Then after drying, you have to wait. You have to check the weight of the product that you obtained. Okay. So this is the overall process, and in the result, you have to write down the weight of the urea formaldehyde polymer or resin that you have obtained. That you have to write. Okay. So this is the procedure. It's very simple procedure. It's very easy. You have to just mix, and you will get some solid. You have to dry that solid. You have to wash and dry that solid, and you have to check its weight. That's all. Okay. So there are some precautions also in both steps. We are using some acid, so you have to use acid carefully. Okay. And you have to stir the reaction mixture constantly. मतलब कि जब आप HCl डालोगे या मिक्स करोगे मटेरियल इसके अंदर बीकर के अंदर, you have to stir. You have to perform stirring with the help of glass rod continuously, regularly. Okay. So that you have to do. So this is all about today's practical. Okay. This is interesting. Okay. Because I never tried this thing. I know we can do easily, but I never did. But if you get the chance to perform this experiment, I will also learn something. Okay. This is easy practical. We can, I think, you can finish within 30 minutes. All over the both of the practicals you can finish in 30 minutes. It's very easy. Just mix and you will get your polymer. ठीक है, अभी समझ में आएगी बात सभी को?
Yes, sir.
ओके. चलिए, ये मुझे लगता है मैंने आपको जो 6th प्रैक्टिकल है वो भी नहीं भेजा है. 6th and 7th प्रैक्टिकल आई विल शेयर विद यू पीपल इन योर ग्रुप्स. क्या है वो मैं आपको शेयर कर दूंगा. एंड देन you can write, okay, in your files. So let me take your attendance. मुझे लगता है 2-3 बच्चे क्लास में थे, अभी मेरे ख्याल से डिस्कनेक्ट हो गए हैं. तो if you know then you can tell me. आज है 31st. Okay. So we have Aditya Dubey 54.
Yes, sir.
Okay. 70. Then we have Aman Kishore 74.
Yes, sir.
Then we have Aman Sharma 64. Aman Sharma 64. Then we have Arif Ahmed 56. Then Arun Kumar 73. Then Ayush Chaudhary 71. Then Chahat Sharma 57. Then Gautam 47. Just wait. Ipshita Dalai 81. Then Kamya Jain 60. Then Karthik 76. Then Khushi Rawat 72. Then Namit 48. Praneet 53. Priyanka Shah 79. Okay, 79 Priyanka Shah. Okay, then Rahul Kanwar 68. Then Raj Jaiswal 59. Sarthak Jain 80. Shashwat 67. Shreya 42. Swati 58. Tanishq 49. Ujjwal Balaji 43. Urbi Vishit 52. Vanshika Sharma 44. Vidhan Pandit 51. Vidhi Pandit 50. विपुल भारद्वाज 41. अच्छा, इसके अलावा भी और कौन कौन रह गया है? इफ यू नो यू कैन टेल मी. मेरे ख्याल से तीन बच्चे और थे. किसी को पता है अभी? वर्षा रेड्डी थी आज 78. क्षितिज 77. नो. 75 लक्षित था भी.
क्षितिज प्रेजेंट है.
क्षितिज प्रेजेंट था. क्षितिज लक्षित. ओके, वर्षा रेड्डी का पता है कुछ? वो प्रेजेंट थी. देन ये कौन है अभी? रोशन भानु 69. अभी प्रतिमान भी प्रेजेंट था अभी. प्रतिमान यार उसको पूछना. ये रोशन भानु को पूछना 69. ये कहाँ रहता है?
ठीक है सर. श्रीनिवास भी प्रेजेंट था.
श्रीनिवास ने 162. अच्छा, ओके. अच्छा, ये 64 कौन है अभी? अमन शर्मा 64. इसका कुछ पता है? अमन शर्मा 64. चलिए, एक और 69 है. ये कौन है? रोशन भानु 69 है. और हमारा 55 कौन है? निश्चय राजपूत. चलिए, 46 कौन है? गौरव 46. गौरव ये आया था क्लास में? गौरव कितनी आया था
सर प्लीज.
चलिए ठीक. कौन कौन प्रेजेंट था?
सर 56.
56 लगा दिया अभी. 56 हो गया. चलिए, अगर कोई और बच्चा रहता है ना, यू कैन सेंड मैसेज.
सर रोशन प्रेजेंट था.
रोशन प्रेजेंट था 69. ओके, ठीक
Yes,
है. ओके, अभी अब्सेंट कौन कौन है इसमें? एक 46 है गौतम. एक 66 है उज्जवल शर्मा. क्या नाम है इसका? उज्जवल शर्मा नहीं था. ठीक है. और एक दो बच्चे और थे. ठीक है. 78 वर्षा रेड्डी नहीं है. ठीक है. जो बच्चे नहीं है यू कैन टेल देम. अगर जो डिस्कनेक्ट हो गया फिर भी आप एक बार ग्रुप में डाल देना. ओके, एंड दे कैन टेल मी. ठीक है, इन द नेक्स्ट 30-40 मिनट्स. आफ्टर दैट आई विल मार्क योर अटेंडेंस. ओके, सो आई विल स्टॉप हियर. आई विल सी यू गाइस नेक्स्ट वीक. अच्छा, भी असाइनमेंट सबमिट कर दिया सभी ने? अभी मैंने चेक नहीं किया. कर दिया सभी ने?
यस सर.
Yes, sir.
ओके ठीक है, अच्छी बात है। ठीक है, आई विल सी ओके कि आपने आंसर ठीक लिखा है कि नहीं लिखा। ओके, सो आई विल स्टॉप हियर। आई विल सी यू गाइस टुमारो आफ्टरनून during your theory class. Okay, stay safe, stay healthy. Bye everyone.